All right, ladies and gentlemen, we are talking about lesson 8.5. We're going to be starting the process of our factoring and using that to help us with our abilities to undo the distributive property. So there's a couple things that we need to understand. Number one, there's this vocabulary word called factored form. And a factored form is the product of prime numbers and variables, and no variable has an exponent that will be greater than 1. So we're going to be taking and breaking down our numbers into their most prime nature. And you've done these things before in the past. This was like the long expanded way of writing things down. So what we're going to do is we're going to break our monomial of 18x to the second power y to the third power into the three pieces that it is. It's an 18, an x to the second, and a y to the third. Now I'm going to put a line underneath them so that we know that we're going to break them down into smaller pieces. So 18, you might have done this by breaking it down by using factor trees. So a factor tree for 18, two numbers that multiply to make an 18 will be a 9 and a 2. Now because 2 is prime, I circle it. We can break down a 9 into two threes. So with that information, we're going to have ourselves a 2 times 3 times 3. And we write them in order from smallest to greatest. Now I wrote 2 for some reason there. I'll fix that quick before you guys tell me that I made a mistake. And then we can break down x to the second power. X to the second power breaks down into just an x times an x. So on our bottom part here for our answer, it's an x times x. Same thing with the y. We can break our exponents into y times y times y. It makes a y to the third. So this would be factored completely of the 18 x to the second y to the third turns into this. This is the long expanded form, the factored form. So we'll do the exact same thing for example number 2 here, or A in example 1. This was example B from example 1. So the number 15 can break down into a 3 times 5, because these are prime numbers. They cannot be broken down any further. And then we'll have 3 A's because it says A to the third. And we will have 2 B's because it says B to the second. So that guy turns into this. And that's pretty much what you have to do when it says the directions for factoring completely. Now some of your other directions are going to say to find the GCF, which will be able to use the exact same kind of a process, but we don't necessarily have to use that process. So if we look at the numbers 27, A to the second, and a B, and then a 15, A, B to the second, and C. What we're trying to find is what are numbers that we can divide out of both of these that are going to be their GCF. So what's the greatest number that I can divide out of a 15 and out of a 27? And the thing that comes into my head would be a 3. That's the largest number that I can factor out of it. Now if I look at the next one, are variables of A's. Now A's, I see that there's a A to the second here and just a regular A. So the largest set of A's that I can take out would just be one of the A's. If I look to the B's, the largest number of B's that I can take out would be just one of the B's, so a B to the first power. So we took that out of both of those. And now what would be left over, if we can think about this, if we did 3AB that we divided out of this one would be left over with a 9, and a will be left over because we divided out the B, and we divided out one of the A's, and we divided out a 3. Now if we do the same thing over here, the leftover piece would be a 5. The only A is gone. One of the B's left, so there's still a B left over, and a C is left over. So we'd have a 5BC left over. Now that process, folks, is something that we're going to be using more in the future, but this is what we found for our GCF. So officially our answer, our GCF is 3AB. Now on my website under the Chapter 8 videos, you're going to find a form that I'd like you to fill out for answering this specific question. When we have an exponent, if you use the caret key, you'll be able to signify that you have an exponent to some power. So if your exponent was like 3 x to the second power. You could show it like that. 3, an x, a little caret key, and then the second power, or a 2 for the second power. I have one more example for us. It says that we're supposed to find the lengths of the sides of a triangle that are 12wz squared, 8wz, and 16w to the second z. Our job is to find the GCF of the three lengths. So you're going to take, and we have three numbers this time that we're going to be using to find all the information for our GCFs. So make sure that you write all three numbers and break them apart and put that again on the answer form for my website. All right, folks, wish you the best of luck. This is Burma Nation, signing off.